When given this assignment for our discussion this week, most of you responded that you tried to do something like this, but without paper. You did this in your head, but you still thought of this process as writing 5 below 18 and multiplying 5 first into 8 and then into a 1. What you were doing in reality was the following. You were trying to say that 18 is same as 10 and 8, and that multiplies by 5. 5 distributes into one of those at a time, and 5 times 8 gives you 40, and 5 times 10 gives you 50, and when you added up those together, you got 90 as your product. We do this in a shorthand format in this vertical setup by not writing out 50 and 40 separately, but by saying 5 goes into 8, 40 with 0 going on in a ones place and 4 carried over to the tens place value. And then 5 times 1 tens gives you 5 tens plus 4 tens more gives you 9 in the tens place value. So this is what really is happening there, except we developed this shorthand form where we can multiply smaller numbers, larger numbers using this approach. And when you work with larger numbers, they get sometimes out of hand. They're hard to work with. Let me demonstrate that for you. As you can see, in this example, we need to multiply two 3-digit numbers, 987 and 564. The result you see right now on the screen, the product is 556,668. Process can be a little, confusing, I guess, and a lot of times students lose some information here and there. Misalignment sometimes a problem, so people use graph paper to make sure everything is aligned the way it should. And there are lots of things that may come up when this process is taking place. I would like to demonstrate another approach to doing the same problem, and this approach will guide us towards multiplying polynomials. That's really the reason why I show this method right now. So let's say I want to multiply 987 by 564 using the so-called box method. Since I have 3 digits in each number, I have to create a box that will have size of 3 by 3. My rows and columns will be responsible for the place values of my numbers. So let's consider 987. 9 standing in the hundreds place means there are 900 in there, so I write down 900 above the first column. 8 tens means 80, 7 ones means just 7. 5 hundreds means 500, 6 tens means 60, and 4 ones means just 4. Now it's time to make sure that every cell is filled out by multiplying corresponding numbers. So first cell will have a product of 900 times 500. Multiplying with zeros is really easy. Just ignore zeros for the time being. Multiply 9 times 5 to get 45. And then follow that by both numbers zeros combined together. So I've got 2 zeros in the 900, 2 more in the 500. That gives me 4 more zeros to apply to 45. So I really got 450,000 there. Continue. 8 times 5 is 40, followed by 3 zeros, or 40,000. And 7 times 5 is 35, followed by 2 zeros, 3,500. Finish the rest of the table. So 9 times 6, 54, followed by 1, 2, 3 zeros. 6 times 8 is 48, followed by 2 more zeros. 7 times 6 is 42, followed by just 1 zero. 4 times 9, 36, 2 more zeros follow. 4 times 8 is 32, just 1 more zero. And 4 times 7 is simply 28. Whatever is inside of this box, when you combine these quantities together, you'll get your product. So let's take a look. Instead of writing out 9 quantities, aligning them and adding them up together, which is fine to do, I typically look for easier ways of doing that and use my mental computation skills to come up with maybe fewer chunks. For example, I'm going to add 450 right here, hold on. I'm going to add 450,000 and 40 more thousand. That gives me 490,000 and 54,000 more. I can do that in my head. 490 plus 54 more, that's 544,000. So I'm going to write that down. That's the combination of these three entries. What else I can easily do in my head? Let's take a look. For example, what if I combine these two quantities right now? That's 3,600 and 4,800. 36 plus 48, that is 8,400. And then I will add 3,500 later. So 8,400, 3,500, and I think I can do combination of these three without much of a trouble. So 400 and 300 is 700, and 28 more, that's 768. When I add these together, let's see what I'm gonna get. Zeros plus 8 is just 8. Zeros plus 6 is just 6. Here I have a 9 and a 7. That's 16. 6 here, 1 carried over. 5 and 8 is 13 plus 3 more 16. 6 here, 1 carried over, which makes this a 5 and that a 5. Did I get the same result? I think I did. It's the same result as before, but I have used a different method. The area model is behind the box method. In other words, when I multiply two corresponding entries to find the product that I write into each cell, in reality, I'm looking for the area of a rectangle that this cell represents. So when I multiply 900 by 500, I am really multiplying length and width of a rectangle that has area of 450,000 square feet. And the same principle applies to every piece of this large 3x3 box. I find 9 individual areas, then I combine them by adding together, and I have the total area of the 3x3 box. So we are going to use the same principle to multiply polynomials.